Hi, this is Mrs. Davis. This is AP Pre-Cal, Unit 2A review packet, and this is the start of the short answer questions. So for number 1, it says, find an equation that gives the nth term of each sequence. Doesn't say whether they're geometric or not. Instead of the initial value, use the kth term of the sequence in your equation. K is given for each problem, so we have K. All right, so that's just remembering the formulas. So the first thing we need to do is figure out whether it's arithmetic or geometric. So it looks like this is plus 20 each time. So we would have an arithmetic, so D would be 20. And if K is 2, then we're given this kth term, so that would be 2 136. So that means that A of 2 equals 136. So we can use that to write our formula. So A to the n is equal to 136 plus D times n minus 2. Okay, and that's just knowing that formula. Let's look at the next one. 2 to 2/3 to 2/9 to 227 looks like it's a ratio of 1/3. And K is 1, so we have the first term. So that would mean G of 1 is equal to 2. So again, using the formula for a geometric sequence this time, we get G of n is equal to 2 times 1/3 to the n minus 1. Again, just knowing that formula. Make sure you have that memorized. Okay, for the sequence 8, 5, 2, -1, what's the 315th term? This looks like it's arithmetic because if you take away 3 each time, so we have D equals -3. And we can use any of the terms to try to figure out what the 3/15th term is. So let's just use A of 1 equals 8. So first we have to get our equation like we did above, and then we have to write the function. So we have A to the n is equal to 8 plus or minus 3. Let me fix that better. It's because it's -3, so it should be minus 3. So minus 3 to the n minus 1. So A to the 3/15th would be 8 minus 3 to the 3/14th. And so then you have to do 314 times 3 is 942. And then take away 8 from 942, and you get -934. So A of 315 is -934. There we go. Okay, a function has the following points. Could it be a linear, exponential, or neither? So we're seeing that we go up by 1, 3, 4, 5. So we're just looking from 6 to 11 would be plus 5. 11 to 16 would be plus 5. So we're going to say that's possibly linear. Looking over here, we go up by 1 again. And we go 3 to 6, but then 6 to 12. So it looks like that's 6 over 3. That would be like a ratio of 2. So this is possibly exponential. Okay. And number 6, the following function is either linear or exponential. Which is it? Justify. So we're going up by 5 each time. So that's nice. So then we can just look. Looks like we're adding 3 each time. So this says, and we have to say justify. So we're going to say, it says, is the function is linear because And now talk about the change in x and the change in y, but call it input and output, because for each input change of 5, the output changes at a constant rate of 3. So remember to talk about the input and the output and what they're changing. Okay, bye. All right, let's go on. I think we can still work this out in this video. Okay, so we have, is it linear or exponential? Identify the constant, slope or ratio that causes the output to change. So we have y is negative 3/5 x. So this is definitely exponential. And you have r is 3/5. Okay, the next one, you could rewrite this as 6 times x minus 4 plus 7, which is definitely linear, right? That's the point slope formula. So the slope equals 6. All right, let's look at 9. It's known that y is an exponential function and it passes through these 2 points. Write an equation for the function. All right, so we are going to look at, the easiest way is to use the formula for a geometric sequence. So we're going to use g to the n equals a to the k r times n minus k. And we can start with either point, but we'll just start with the 3, 6. So g to the n is equal to 6r n minus 3. So then putting in 942 to find r, we have 42 equals 6r to the 6. So 7 equals r to the 6. So r is the 6th root of 7. All right, so then we can say that, go back up here, g to the n is equal to 6 times the 6th root of 7 to the n minus 3, or y, because they want it y. They don't want it sequence. Y equals 6 times 6th root of 7 to the n minus 3. Over here, we have 4 times 4 times 4 times 6. It's an output for an exponential function, a, b to the x. A and b are constants. Write the function along with the input value that represents the output value. Okay, so we have, look at this, 3 4s. So we're doing 4 to the 3rd, and then we're multiplying it by 6. So we have 6 times 4 to the x, and x is 3. Number 11, identify the exponential function is growth or decay, and justify. Okay, so we have to justify. This is definitely our b is less is greater than 0 and less than 1. So this is decay because b is between 0 and 1, and a, which is equal to 1.4, is greater than 0. For number 12, we have 1.7, and they want to know if this is increasing or decreasing. So this is growth, right? And so growth looks like this. And so this would be increasing because it's exponential growth. It doesn't ask, but it might ask you, so we'll put that on there for knowledge purposes. Now we're looking at f of x is negative 6 to the x. Is it concave up or concave down? All right, so we're going to sketch this too. 6 to the x would go like this, but then it's reflected over the x-axis, so it's going to go like that. So we're going to have concave down. Again, you're going to sketch, right? You're going to sketch that this is the final graph. Okay, let's look at the next one. We have the limit as x goes to negative infinity. We want to find that for this function, which is decay, because b is less than 1. So it looks like this, right? And so we just need the limit as x goes to negative infinity, which would be positive infinity. So the limit as x going to negative infinity of f of x is positive infinity. And again, we did that from a sketch. This is from a sketch. Okay, so there's the first video in this set.